Hello, Algebra 2 Honors students. We are starting Chapter 11 today, which is graphs of sine and cosine, which is something you will definitely talk about in your future math classes. So sine and cosine are both called periodic functions. Notice that they put the fun in functions. And some of our key concepts that we're talking about today are that periodic functions are functions that repeat exactly in regular intervals, and these intervals are called cycles. The length of the cycle is called its period. So the periodic functions, we say it repeats every period. We are going to examine the graphs of these periodic functions, and there's a periodic and a non-periodic one below. And the cycle can begin at any point on the graph. One thing you'll notice is often we'll draw like a little line from one period to the next. So if you notice in between these two, it's the same pattern, and then that continues to repeat over and over again. A lot of times you might hear it say like crest to crest, the top of the wave to the top of the wave, or the bottom to the bottom. And then this would be an example of one that is not periodic. It does not repeat itself over and over again. Page 754 just gives you a couple more examples. So if you wanted to look at a couple more of those, it's asking you to identify if it's periodic or not. So here, this is going to repeat, and to find the period, you can just count. So this is -1, and then it reaches that same point again at 1. So that would be a distance of 2. So the period would be 2 in that case. B, even though it is symmetric, it's not repeating itself. You would have to have, after you do this pattern here, it would have to be the same exact one. Okay, and then even though it's symmetric, it does not repeat exactly. So we're going to look at a couple more examples together. So we're going to identify if the function is periodic, and if it is, then we're going to say what the period is. So if you look here, again, we can compare from the top of one to the top of another and see, does it repeat this pattern exactly in between the two crests, or in between the two troughs here. And this one looks like it does. So it does repeat exactly. So yes, it is periodic. And so we're going to find the cycle of the distance that it takes. So identify the period by using the start and finish of one cycle. In this case, I like to start at what would be considered 0, which is here. And at 0, it looks like I cross right here. So I would just keep going until I find where it hits that same part. So it's on the downswing. So if I go on the downswing here, where it hits at 1, I'm at this point here. So from 0 to this point here, it looks like it's pi units. So pi would be your period. This one is not periodic, like we mentioned before, even though it is symmetric, like it's going down here, but then it's going up, so that's not the same. For C, the level keeps going up, so that is not periodic. It is not repeating itself. It has to repeat. This one is a little bit tougher. So here we can see this part looks like it's the same, and then this part looks like it's the same. What you can't see is where this is going. This is a popular function. It's the graph of a tangent, which you guys will study in 11.2. So if we go from here to the middle, that would be one way that you could look and see, does it hit the same part, or the top of the arrow to the top of the arrow? And so this would be 1, 2, 3. You can see these are both like a little bit past it. So this one is yes, it is periodic, and the period would be 3. And I do think it would be easiest to count from the arrows. So it's about 1, 2, and then 3 there. All right, now we're going to talk about the graphs of sine and cosine. You can relate these to the unit circle. This is the trig functions that you studied in chapter 13, except we did not study chapter 13, and there is no 13 even in your book, so I'm not sure why they put that in there. It's the trig functions we studied in chapter 10. Those are periodic. So you can graph the function sine of x on the coordinate plane by using your points from the unit circle. Okay, so you can graph the function on the coordinate plane. In this case, for the sine in particular, remember that the sine were the y coordinates. So you can use the y coordinates from the points on the unit circle. And then it just says where the independent variable x represents the angle theta. And then you could also graph cosine by using which point on the unit circle? So cosine can be graphed by using the x coordinates. So here's some examples below. A lot of these were taken from your textbook. In this chart here, it's using x and y, but in this case, your x is your theta. So at pi over 3, your y coordinate is root 3 over 2, and then that is right here on your graph. So remember that the point here is 1/2 root 3 over 2. So at pi over 3, the y coordinate is root 3 over 2. At 5 pi over 6, the y coordinate is 1/2. At 4 pi over 3, it's negative root 3 over 2. At 11 pi over 6, it's negative 1/2. So that's why they're saying, oh, you can use this to find all of your points. Now, when you're graphing, you're not necessarily going to want to graph the root 3 over 2 because it will be a decimal. So let's look at some of these points on the graph of f of x equals the sine of x and find some nice points that we can find. Okay, so the first one is 0. And again, we can relate this back to your unit circle. At 0, your point is 1, 0. So if we're using the y coordinates, okay, if we were to find the sine of 0, that would be 0. So that's why the point here is 0, 0. Okay, another point you can see is at pi over 2. At pi over 2, our point is 0, 1. So if you were to plug in pi over 2, the sine value at pi over 2 is going to be 1. Okay, so let's find the next point that's nice. Right here, this crosses at 0, and that's at pi. So if you did the sine of pi, you would get 0, which makes sense because at pi, your point is negative 1, 0. At 3 pi over 2, that's going to be a nice point as well, because at 3 pi over 2, the sine value is negative 1. So the sine of 3 pi over 2 would equal negative 1. And then this here is at 0, and that is at 2 pi. That would be a full rotation, and the sine at 2 pi is going to be 0. So when we graph, we are going to focus on some of these points that are pretty nice here. Okay, that are pretty nice in terms of the graphing. All right, and then some of you suggested just to do shorter videos so that there wasn't as much of a lag time, so I'm gonna try that for this one. Okay, so then there'll be a new video for the next page.